Hi, this is section 5.7 called Predicting with Linear Models, and we're on page 335. I want to start off by just reviewing a couple things that we did in the last section. The last section, we were drawing a line of best fit. We were fitting a line of data. So in the last section, in section 5.6, we did the following, okay? Oop, I got to turn my layer on. I want to write this out so you can physically actually see it. Okay, first of all, we made a scatter plot of data, okay? Made a scatter plot. The next thing we did is we determined whether that data had a correlation. Okay, and remember, data could have a positive correlation or a negative correlation to it, or it could even have no correlation. So we made a scatter plot. We determined if that data had a correlation to it, and then if it did have a correlation, we wrote an equation for that correlation. Okay, and that's what we did in section 5.6. Now sometimes you might wonder, well, why would I do that? Well, the reason why we do this is we can use this information to help us predict other results, either future results or past results or even results as things are going on. Like when you buy stocks, a person that buys stocks might want to know what the scatter plot is for that stock. Like, I'm going to pause the video for just a second to show you what I'm talking about. Okay, I just stopped the video because I wanted to show you, again, why would I want to use a line of best fit, and how would I use that to help me predict data? Well, here's a stock. I just picked the stock. I own a few stocks. Here's one that I own, and I bought the stock back, I believe, in February, okay? And if you look, there's a couple data trends to the stock. Now, at first, when I bought the stock, and I don't remember when, let's just say at the beginning of February, which would be right here, okay? At first, when you look at the data, and you look at this, and I was a little worried about this at first when I bought this, you can see how there's a line of best fit, and look what's happening. That line of best fit doesn't look very good, okay? And I'll be honest, there was times when I bought this back in February and I got to April and May, I was wondering, well, am I doing the right thing here? Did I do the right thing in buying this back then? And then you can see what happened in May. Things started turning around, and if I want to kind of think of a line of best fit for this data, it might look something like that, okay? Well, you can see there's certain points I could use this line to predict points in between, or I might even, I'm hoping this line continues to go on like this for another half a year because I can imagine or predict what I might have. I don't know if that's going to happen, but I think you can see here's a real life example where a line of best fit and using that line of best fit to help you predict data could come in handy. I know you all like money, okay? I use this kind of thinking or this type of application for money, okay? So that's why we use line of best fit, and just an example of how we might use it. I'm going to pause the video here just a second so I can get back to my other screen. Okay, so being back on this screen now, so again, back in the last section, we made a scatter plot. We determined whether that data had correlation. We wrote an equation. What I'm showing you today is this section is called Predicting with Linear Models. So after we do these things, we can use this information to either predict future results or predict current results. Okay? Now what we're doing, this whole process is called linear regression. And maybe I should write that here at the top of my screen. Linear regression means what you're doing is you're taking data, you're taking points, spell that right. You're taking points and you're applying a best fitting line to model that set of points. Now there's two ways we can do a linear regression. We can do it by hand, that's you making your own estimate, or we can also do it on our calculator. I'll show you both ways, okay? And I think the best way to show you this would be to just do a problem with you. So let's go to number 3 in the book. And number 3, you see a table. And what you see on that table is, and by the way, we're on page 338 right now. You might want to stop the video, look at page 338. Okay? Make a scatter plot of this data, find the equation of the best fitting line, and then approximate the value of y for x equals 5. So we'll get to approximating values afterward. Let's make a scatter plot first. So I got to pick an appropriate scale. You notice the x values go from 0 to 7. That's not a problem. But the y values go all the way up to 20. So if I take graph paper and I go up 1 unit at a time, this is going to kind of go up kind of high. So I decided to go by 2s. I changed my scale for y. Well, let me plot those points, so I'll do that now. So I have the point 0, 2, and 2, 7, and 4, 14, and 6, 17, and 7, 20. Okay? I plotted my points. Now you can notice here this is definitely a positive correlation. So now I'm going to do a linear regression. I'm going to do it by hand. I'm going to apply a line of best fit to that data. Again, this is what a linear regression is. It's when you are the process of finding a line of best fit and writing an equation for it. That's what the term linear regression refers to. You are applying a line of best fit to data. Okay? I have to write an equation for this line of best fit. All this stuff I'm showing you is again, stuff we learned in the last section. So I got to pick 2 points on the line. Now remember, I can't just pick 2 of the points I graphed. You notice none of these points are actually on the line I drew. I got to pick 2 points on my line. So I did. This looks like the point 1,5 and this looks like the point 618. So let me write an equation for those points. So the first thing is I notice my slope. If I use my slope formula, 18 minus 5 over 6 minus 1 is 13 over 5, which is about 2.6. I guess I could have left it at 13 over 5, but I'll just keep it at 2.6 for now. Then I got to take one of my points and plug it in for x because I don't know. This looks like it might cross at 3 on the y-axis for the y-intercept, but I'm not sure. So I better actually plug the point in and check. So if I plug in 5 for y and 1 for x, and I solve, I'm going to find out that b is about 2.4 or 12/5. Okay, and that process I've shown you before. Plug in a 5 for y, plug in a 1 for x. 13/5 times 1 is 13/5. If you take away 13/5 from each side, you would find out that b is 2.4. which is the same as 12/5. So I guess you could put it in decimal form or fractional form, okay? Now, the next thing we have to do, and I got to erase this. I have some writing underneath here from what I wrote up here earlier, and let me get that out of the way. Which I guess I could have just turned that layer off, but okay, now the next thing we're going to do, and the last thing they asked us to do in this problem, is it said approximate the value of y for x equals 5. Now, when they ask you to approximate the value of y when x equals 5, take a look at this graph. Do you notice how x equals 5 is in between the other data that we graphed? Like 5, the point for 5 would be somewhere probably here in between these other points. When you are estimating a point inside your given values, that is called interpolation. That sounds like a fancy word. Sounds like a big word. All in interpolation, it kind of means inside. I am estimating a point inside the other points. All you have to do to find the value of y when x equals 5 is you take 5 and you plug it in for x. And so if I take, I'll just do it here, if I take 2.6 times the 5, which I'm plugging in for x plus 2.4, when I do that, that's going to give me 15.4. So plugging in 5 in my equation gives me 15.4. Let's see how close that estimate would be to my other data. Here's the point 5. Here's the point, 15. You can see my line is giving me an estimate that the point 5, 15.4 would be on this line. Okay? That's called interpolation. All right? So we can do a linear regression by hand. That's typically how I would do it. Okay? I think the next problem I will do with you on the calculator just so you can see it done both ways. Okay? So the second problem we're going to do is going to be problem, or actually I guess I'm doing number 3 again. I just wanted to show you one more thing before I move on. Okay? Just putting all this back up here. Okay, have that same thing. I wanted to go over what happens if we estimate a point outside the data. Now, in the last slide, I estimated a point inside the data. I estimated the point 5, x is 5. That's called interpolation. If the problem had asked us to estimate a point, like let's figure out what the value of y would be when x is 10. Now, x is 10 is way out here. Okay? If I wanted to estimate the value of x is 10, do you see how x is 10 is outside the rest of our data? It's out here somewhere. It's out beyond the rest of the data. That term is called extrapolation. Extrapolation is when we're estimating a point outside the data. Okay? So, if I estimate a point outside the data like x equals 10, I would do the same thing. I would take 10 and I would plug that in for x, and if I take 2.6 times 10 plus 2.4, that's telling me y would be 28.4. That's an example of extrapolation. Okay? So interpolation is estimating a point inside the data. Extrapolation is estimating a point outside the data. Okay? And one more time, when you do the process of plotting a scatter plot, drawing a line of best fit, and writing an equation to represent that line of best fit, that whole process is called linear regression. Okay, let's do one more problem, and then I'm going to talk about finding the zero of a function. Why don't we go to question number 5 in the book, and let's do 5 on our calculator. Instead of doing it by hand, we'll do it on calculator. So let me pause the video. Okay, the reason I pause the video is, as you can see here, I have my calculator up, and to enter and to get a linear regression, the first thing we have to do is we have to enter the table in our calculator. So remember, to do that, we got to hit the stat key first, and we're going to edit stats, and we have to enter this table in our calculator. So let's do that. X is 0, x is 1, x is 2, x is 3, x is 4, x is 5. Okay? And then we can enter the y values in our calculator. So let's do that next. That'll be under list 2. X is 20, x is 32, x is 39, x is 53, and x is 64. Now, I want to graph these, okay? I guess one thing I should say real quick, if you couldn't get your calculator to here by hitting the stat key, if your calculator is screwed up, remember, if you hit second plus 712, it will clear your calculator. It should set everything up back, and you ought to be able to get to here by hitting the stat key and get caught up with us again. Okay? So I have those points in my calculator. Now what I want to do is I want to plot them on graph paper. My calculator can do that for me. Do you see where it says stat plot above the Y key? Go ahead, hit second and then the Y key, and you have a bunch of different plots you can do. We can just use the first option of plots. We want to turn this on, so press enter if it's not already on. And then it asks you for these different types of graphs. Okay? And I want to have a scatter plot. Okay? So I'm going to arrow on down. I want a scatter plot. One thing that bothers me, it says I have a dimension mismatch here. X list 1, X list 2. Let me just double check what I entered in here, make sure I got this entered in right. Oh, I got a 5 in here. I got to get this 5 out of here. That's why I don't want 5 on there. Let me clear that out. Oops. I got to delete that one. There we go. Okay. So got to make sure that every X entry has a Y entry. I had an error message on that screen, so I had to make sure. So let me go back to this again. Go back to my stat plot where I was before, and I want a scatter plot. My X's are list 1, my Y's are list 2. Now, before I graph this, or if I hit graph, let me just hit graph, you won't see anything. And you might be like, why in the heck don't I see anything? Well, see, look at this graph carefully. The X values go from 0 to 10, and the Y values go from 0 to 10. But look at my table. The table in your book, the Y values are from 20 to 63. I have to change my window to show that. So let's go to the window. I'm going to change my Y values. I'll keep my minimum at -10, but I'm going to go all the way up to 70 for my Y values because I got to get this graph all the way up to 70. Now, if I go and hit graph now, oh, can you see these points? Now, that's what it would look kind of like on graph paper. There's some points there, and you can definitely see we have for ourselves a positive correlation going on right now. So now I want to get a line of best fit, okay? I need to do what's called a linear regression. The calculator can do it for me. If I go to my stats key again, go to calc, do you see how option 4 says lin reg? That means your calculator will take this data in the table, and you know how on paper you wrote a line and you figured out the equation of the line? The calculator can actually figure out the equation of the line for you, okay? So let's go to that and press enter twice. Okay, here's what this is telling me. This is telling me that my equation is y equals 10.7x plus 20. And I'm just going to write that up here real quick. Y equals 10.7x plus 20 is my equation for that line in slope-intercept form. Actually, let me show you that on this calculator. If I type that in let's go to the y equals key and check this out now. This is kind of cool. If I type in 10.7, I believe it was, x plus 20, look what happens when I graph this line. This is cool. You see how that looks like the line of best fit? Okay, so there is my line of best fit. Now, what they want me to do in number 5 is they want me to do a linear extrapolation. They want me to find the value of y. They want me to find the value of y when x is 10. So remember, this was my equation. Well, to find the value of y when x is 10, all I got to do is plug in 10 for x. And I can do this in my head, actually. 10.7 times 10 is 107 plus the 20. That means 107 plus 20, 127. So that means when I entered in 10, this is estimating the point 127. That would be an extrapolation because the point 10, 127 would be way out here somewhere on my calculator. Okay? So I've shown you both ways to do a linear regression. Okay? You can do linear regression by hand on paper. Okay? By hand on paper. And honestly, that's how I would typically do it, because by the time you're done fiddling in, typing points in and all this stuff, you know, if you do it on paper, you probably have it done, although you can use your calculator. And I don't care which way you do it. Now, I would on quizzes and tests ask you to actually draw your line of best fit and plot the points. So again, if you're having to draw that out, it just seems to me like, you know, this is a little bit quicker, but that doesn't mean you can't use your calculator, all right? There's one last thing I need to show you, and then I'm going to stop the video. They're also going to ask you to find the zero of a function, and that's on page 339, questions like 7 to 12, and what is that asking us to do? Okay, so when they ask you to find a zero of a function, what is that? It means they're asking you to find what value for x would I plug in to make this work out to 0. In other words, I want to find out what number can I put in here so that that is nothing. So in other words, f of x, I want that to equal 0. So all we have to do is make f of x equal 0. So plug in 0 for this. So replace f of x with 0. In other words, y is 0. So I want 7.5x minus 20 to work out to 0. That's what it means to find the 0 of a function. I want to know when is this going to equal 0? Well, solve now. Add 20 to each side, divide by 7.5. 2 2/3 is the 0 of the function. In other words, I got to plug 2 2/3 in for x to make this whole thing work out to 0. Okay? See if I have, and that's the last thing I had to cover. I don't think I have to go over another example of that. I think that explains it. Okay? If we do have questions, we can go over those tomorrow.